This is a National Foam 600-gallon bladder tank proportioning system. Consisting, the main components is the steel pressure vessel, which contains an internal bunanitrile bladder, and inside the bladder is currently filled with 600 gallons of 6% fluoroprotein foam. The other main components of the system are an isolating inlet valve, which isolates the system from the firewater main, a water inlet pressure gauge to the system, a system Y strainer to take out any impurities before it reaches the bladder tank, a check valve which stops any backflow from the system if the system suddenly stops, a pressure sensor here which is connected to the site control and instrumentation system, and we have the inlet deluge valve which ultimately is controlling the on-off of the bladder tank system. Ordinarily, in its normal operation, the inlet valve would be open. We would be reading a pressure which is given to us from the site ring main. Water would then be as far as the inlet to the deluge valve. This deluge valve is held closed by firewater pressure, which is tapped from an inlet pipe into the activation solenoid. In the event that the system is required to operate, the electrical operated solenoid can be fired from the main control panel, and upon initiation of the solenoid valve, this will allow the deluge valve to open and water to then flow to the 3-inch ratio controller which is installed at high level. As the firewater flows to the ratio control proportioner, some of the pressurized water is tapped off into the vessel. So ultimately it is pressurizing the bladder externally and causing the foam pressure to be matched to the same as the water inlet pressure. At the same time, a water sensing line from the inlet of the proportioner is going to open this automatic water-powered control valve. So whereas the deluge valve is giving us a flow of firewater, the opening of the water-powered ball valve is allowing a foam concentrate flow to go from the base of the bladder tank via a non-return valve and through an orifice plate into the proportioner. Downstream of the proportioner, we now have a 6% foam solution when the system is in its normal flowing mode. Outside on the manifold area, we also have foam pourers. Foam solution is injected via an orifice plate at the inlet to the foam pourer, which then causes a jet which entrains air into the discharge piping. This results in a flow of aerated foam onto the floor area, which will cover any spillage within the manifold vicinity. As I explained previously, in its normal quiescent mode, the inlet valve will be open, the deluge valve will be closed, the water supply valve to the bladder tank should be in its open position, and the isolating valve from the bladder tank should also be in its open position. Within the system, the only thing that we need to open is the deluge valve to provide water, and the water power ball valve to allow the flow of foam concentrate into the ratio controller, which will then give us the 6% solution required to generate the foam blanket in the risk areas. During operation, the foam solution from the bladder tank and ratio controller flows into the downstream pipework, and part of the flow is tapped off to the foam sprinklers which are installed on this ceiling pipework. During operation, the solution will flow through the foam sprinkler and at the same time entrain air to give us a foam blanket on the floor. The foam blanket on the floor is designed to cover any spills which may occur from leakage in pump glands or from flanges. Maintenance of the bladder tank system is relatively easy, but it is vitally important that it is carried out on a regular basis and in accordance with the operating and maintenance manual. The fire codes require that for any foam proportioning system, maintenance is carried out 6 monthly and annually. What we would suggest on a 6 monthly basis is a full wet test of the operating system and the supply devices is carried out by using water alone. And to carry out that test, we will carry out an operation of the deluge valve from the control system, but we would ensure that the foam concentrate isolating valve is in its closed position. This then allows us to check the operational and function of the pressure gauge, the pressure switch, the deluge valve, and all of the downstream foam generating devices. On an annual basis and in accordance with the NFPA 11 fire codes, it is strongly recommended that a full-scale foam discharge is carried out from the system. It will be exactly the same test as is performed on a 6 monthly basis. The only difference being is that during this test, the foam isolating valve would be in its normal position, which would be open. The test would then consist of opening the inlet deluge valve, which would allow water to flow to the system, pressurized water to the bladder tank. We would then check that the sensing line opens the water power ball valves and allows foam proportioning to take place. As this is only an annual maintenance test, we would suggest that within 15 to 20 seconds of the water power ball valve opening, the foam isolation valve can be closed down and the system be allowed to flow with water to flush through all of the devices. At the same time as the flushing is taking place, we would check that the foam pourers and the foam sprinklers are all producing water without any restrictions and without any blockages in the pipework. As supplied with the system is a full and comprehensive package of operating and maintenance instructions. All of the bladder filling instructions are in here, which the site operations team have been witness to over the last 2 days, and also they've witnessed the foam quality testing that we've also done. In the middle of the operating and maintenance manual is a comprehensive checklist of each of the individual components of the system and the frequency and the requirement of any maintenance that is needed. So for an operator to go through this list, to check off the weekly, the monthly, the semi-annual and the annual checking of this proportioning system is very, very simple, and it's all very logically laid down and set out. Thank you very much on behalf of National Foam. I wish you good evening.